Hello out there, welcome to this tutorial on vectors. In this video, we'll be looking at component of vectors in two dimensions, position vectors. From the Cartesian plane below, we have our x-axis and y-axis. This is still remaining as the origin. So if we have a vector, call it OA, and another vector OB. When I say the vectors OA and OB are called position vectors relative to the origin O. And from here, we can just name this as A so that OA is equal to A, and name OB as what? B. We can get another vector from A to B. We call it AB. Following the triangular law of vectors addition, you see it is ideal that since this one is going this way, it should be from A to O, then from O to B. So that we have it from A to O, then from O to B. So that we now have it as this is going to give us OA plus OB by vector addition. And the implication is since this O and this O, they are very close to each other, the result is going to be AB, which is this. But we know that since this OA is A, it means AO is going to give us a negative A, and our OB will still remain as B. So that AB, if we rearrange it, it gives B minus A. Which means if you are to find AB, it is going to be the position vector of B minus that of A will give us the required vector in the appropriate direction. So from here, we'll now be solving some problems. The position vectors of the points P, Q, and R relative to the origin O are given as OP equal to 3, OQ negative 1, 5, and OR 4, negative 7. Find PQ, QR, and modulus of magnitude of PR. The position vectors of P, Q, and R are given as column vectors. So we go straight to find solution to the problem starting from A, PQ. We have established that to get the vector PQ, it is the position vectors of Q minus that of P. And the position vector of Q is negative 1, 5. So I have negative 1, 5 minus the position vector of P, which is 3, 2. So we then simplify. Negative 1 minus 3 gives negative 4, and 5 minus 2 gives 3. And that's all for PQ. That's the vector PQ as column vector. So we go to B. For B, we have QR. Again, it is the position vector of R minus the position vector of Q. So we have the position vector of R to be 4, negative 7, minus that of Q is negative 1, 5. So that we now have 4 minus negative 1. That's going to give us 4 plus 1. That will give us 5. And negative 7 minus 5 will give us negative 12. And that's all for QR as column vector. Then we go for the C. For C, we are going to find the vector PR first before we find the magnitude. So we said it is position vector of R minus that of P, and the position vector of R is 4, negative 7, then minus that of P is 3, 2. So in our solution now, we said 4 minus 3, and that will give us a 1, and minus 7 minus 2 gives negative 9, And that's all for the vector PR. So to find the modulus or the magnitude of PR, we're still going to have it as square root of, this is the x component, which is 1 squared plus negative 9 squared. Negative 9 squared is 81 plus 1 gives 82. So we have it as root 82. And that's all for the problems on position vectors. And this is the highest we can take on position vectors. And this is the highest we can take in this tutorial. I hope you enjoyed this video. Please like and share this video. And remember to subscribe to our YouTube channel. Goodbye.